So, again, the biggest difference between permutation and combination is that with permutation, order matters. And with combination, the order does not matter. Doesn't matter. Let's talk about when it's very likely that you would see probabilities involving permutations versus combinations. So when does order matter? Well, that's things like finishing in a race, finishing first, second, and third. Order matters if you finish first, second, or third. Same with being president, vice president, or secretary. Order matters. Codes, when you put your locker combination in, it matters which number you put in first. If you're at home and you're trying to get in your garage door and you're punching in your code, it matters what number you punch in first. Order matters with codes, races, elections. Order matters. Now, when does order not matter? When would we be looking at combination types of problems? Well, there it is. That would be things like people in a group. If I were to pick a group of 5 students and say, you 5 students automatically get an A, it shouldn't matter what order I pick you, it matters that you were in the group to get the A. So when you're in a group, it doesn't matter what order, it matters what group of people are together. So order doesn't matter there. Next, cards being dealt. If you're being dealt 5 cards, it doesn't matter what order, it matters if you have 4 aces in your hand. I don't care what order I got them as long as I got those aces. So order doesn't matter when being dealt cards. And lastly, order doesn't matter when you look at what movies you saw. Now, okay, sometimes I always have students say, well, it matters if you see the sequel before or after. Yes, I get that, but if we're just talking about going to the movie theater in Worthington right now and seeing 2 movies, the movies that are there, it doesn't matter what order. Okay? We're just looking at 2 of them. So, that's the difference between when does order matter and when does order not matter. Let's try an example here. This is a combination example because I say if there are 26 kids in a class, how many different ways can a student or can a teacher pick 5 students? It doesn't matter what order the students are picked. They're not getting prizes for being first, second, and third. They're simply being put in a group of 5. So we would do 26 combinations of 5. I guess I have this all typed out. 26 combinations of 5. And if we use our calculator, this is going to be found in the same spot that permutations are. So if we type in there's 25 total students, and I want to know how many different unique groups can I put together, we're going to be doing combinations of 5 students. How many groups of 5 can I make? Well, I can make 53,130 different groups. Oh, those are not the same numbers because I typed it in wrong. My apologies. There are 26 students, not 25. I typed that in wrong. Let's double check. 26 math combinations of 5. Yep, 65,780. So let's watch that if we type things in wrong. Okay, let's try a little bit harder of a question. This one says a menu has 3 choices for a salad, 8 vegetables, and 6 main dishes. How many different meals are available if you can select a salad, 2 vegetables, and a main dish? Okay, let's talk about this. How many ways are there to select a salad, meaning 1 salad? Well, there are 3 choices for salad, so we should say that there's only 3 options for a salad. Okay? Now, 2 vegetables. Let me ask you something. Does it matter when you go out to eat if you choose your 2 vegetables to be potatoes and corn, or if you choose corn and potatoes? Is that going to be a different meal? The answer should be no, because does it matter what order that you order your vegetables? No, the order doesn't matter. If you get corn and potatoes, that's the exact same thing as potatoes and corn. So order doesn't matter. So if you have 8 options for vegetables and you get to choose 2 of them, that's when we're looking at 8 combinations of 2. And it's combinations because, again, order does not matter when choosing those vegetables. And lastly, for the main dish, notice we're choosing a main dish. That means 1 main dish, and there's only 6 options. So we're only choosing 1 of those. That's 6. So we have 3 options for a salad, 8 combinations of 2 options for a vegetable, and 6 options for a main dish. If we type that into our calculator correctly, we should find find that there are exactly 504 different options for meals. Okay, moving on. Let's try some of these card ones. Cards are combinations because order does not matter. Okay, if there's a 52 card deck, and here's your deck of cards, there's 4 suits, 13 kinds. How many ways are there to be dealt any 5 cards? Well, how many total cards are there to choose from? The answer is 52. And how many am I being dealt? 5. Again, does the order matter? No. That's why the number of ways to be dealt 5 cards is simply 52 combinations of 5. And if I take 52 combinations of 5 in my calculator, I find that there's actually 2,598,960 different ways to be dealt any 5 cards. Now, how many ways are there to be dealt 5 cards that are all the same suit? Well, this one gets a little tricky because first, which suit? I don't know, it didn't say. So what we have to do first is to pick a suit. And if you notice, there are 4 suits to choose from. So I'm going to start this by saying 4 combinations of 1. What that's doing is picking a suit. Once I have picked a suit, let's say I chose hearts. Okay? Now I want to know how many ways are there to be dealt 5 of the hearts. Well, if you count, there are 13 hearts total, and I want to be dealt 5 of them. So how many ways can I be dealt 5 of them? That's when I would take 13 combinations of 5. So 4 combinations of 1 chose a suit, and 13 combinations of 5 told me how many ways I could be dealt 5 of those 13 cards. If we multiply those out correctly, you should find that there are 5,148 different hands available. Now, how many ways are there to be dealt 3 kings and 2 other cards that are not kings? Now this is very specific, 3 kings. How many ways are there to be dealt 3 kings? Well, let's think of part and total. How many total kings are there? There's 4 total kings, and I'm going to be dealt 3 of them. So the first part of this should be picking the kings. 4 combinations of 3 tells me how many ways I can be dealt kings. And so we're going to multiply how many ways are there to be dealt 2 other cards that are not kings. Well, if we look at the deck, there are 52 cards total. And if I say I don't want kings, that means I'm taking out these 4 numbers, which means I have 48 other cards to choose from. So out of those 48 cards, I want to be dealt 2 of them. So we're going to multiply on by 48 combinations of 2, and that tells me how many ways I'm being dealt 2 other cards. So to get exactly 3 kings and 2 other cards, I'd have to first figure out how many ways I can be dealt 3 kings, and then figure out how many ways I can be dealt 2 other cards. If I multiply those out, I find that there are 4,512 different hands that deal 3 kings and 2 other cards. Alright, that was combinations. Okay, this is all going pretty fast. Let me review with you for just a moment. Whoops, I didn't really want to do that. Please remember, you have a few options here. We have permutations, order matters. Combinations, order does not matter. And the good old fundamental counting principle, where we are simply multiplying the number of ways things can happen. So what's going on here is I have a mixture of these problems. I'm going to read them, pause for a minute, and hope that you can pick the right method. Should I be using fundamental counting principle, a permutation, or a combination? That's actually the biggest part of this whole lesson, is being able to choose which one you need. And the best way to realize the difference is think, does order matter? Okay, here we go. Let's give it a try. First one, it says, in a track event, there are 9 runners. How many different ways can they place first, second, and third if we're dealing with no ties? How would we take care of this? Will we use that fundamental counting principle, some kind of permutation, or a combination? Hopefully you're thinking permutations, because you're finishing first, second, and third, which means order matters. So to figure out this problem properly, we have to realize we have 9 runners total and 3 places for finishing. So what we're going to need to do is take 9 permutations of 3 And if we take 9 permutations of 3 on our calculator, we get 504. Now I will say, if you thought about it as 9 times 8 times 7, you will get 504 because those mean the same thing. Okay, let's try the next one. How many ways can 10 people line up in a row for concert tickets? Would this be some kind of fundamental counting principle? Would this be a permutation or a combination? Hopefully you're thinking permutation, because does order matter when you line up for concert tickets? I'm going to say yes, because what if after 6 people they're sold out? Matters if you're one of those first 6 people or if you're in the last half, okay? So order matters here. This is a permutation. Actually, the best way to find this one out is to take 10 factorial, or that's the same thing as 10 permutations of 10 if you're thinking in terms of permutations, because order matters. They both mean the same thing, and if you multiply them out, we find that there are 3,628,800 different ways for just 10 people to line up in a row for concert tickets. Okay, let's try the next one. A florist has 12 different flowers from which a floral arrangement can be made. If a centerpiece is to be made using 5 different flowers, how many different centerpieces could be made? Okay, fundamental counting principle, permutations or combinations. Hopefully you are thinking combinations. Why combinations? Because order does not matter. Does it matter if I choose roses and then carnations, or carnations then roses? No, the arrangement is going to look the same. Order doesn't matter. It doesn't matter what order I pick the flowers, roses, carnations, daisies, or daisies, roses, carnations. Order doesn't matter. They're going to look the same. Okay? So order does not matter here, which means it's a combination. Now there are 12 total options, and I want to choose 5 of them. Out of 12 total options, I want to choose 5. So to correctly find this, we would take 12 combinations of 5, and if we type that in our calculator like I showed you, you should get 792 different flower arrangements. Okay, next one. If you can choose from 3 flavors of ice cream, 5 toppings, and 3 sizes, how many different ways are there to order your ice cream? So ordering ice cream, we're choosing from 3 flavors, 5 toppings, and 3 sizes. Would this be a fundamental counting principle, a permutation, or a combination? If you said fundamental counting principle, you are correct. This is neither the permutation or combination. This is simply, I am given 3 options, and then 5 options, and then 3 options again, and I simply need to multiply my number of options. I'm only taking 1 of each. I am multiplying my number of options. Choosing a flavor of ice cream, choosing a topping, choosing a size, and there are 45 different ways to order your ice cream. Okay, let's try one more. How many ways can a 4-member committee be chosen from 15 people? Fundamental counting principle, permutations, or combinations. Hopefully you're thinking combinations, because I'm choosing 4 people to make a committee. It doesn't matter which order I choose them, it matters who's on the committee. So the order doesn't matter, which means this is a combination. So there are 15 people to choose from, and I'm going to take 4 of them. So out of 15, I'm going to choose 4. So I'm taking 15, choose 4, 15 combinations of 4. Again, typing that in your calculator correctly, you should be left with 1,365 different ways to form that 4-member group out of 15 people. Okay, that was a lot of information. That's all I have on permutations versus combinations. Remember, if you're using permutations, order matters. If you're using combinations, order does not matter. Order does not matter for combinations, but it does matter for permutations. Keep that in mind, and hopefully you'll do well on those questions.